Today we discuss the Python courses. The course we discussed Python course, and we earlier we discussed the topic that is static class method, decorator and MetaClass. And so today we discuss the uh, we discuss like that is a that is decorators decorator state retention options. Yeah, this was. So earlier we discussed the class related methods, that is instant method, static class methods, and decorator we discuss what is a decorator, managing calls and instance like function decorator and class decorator. So function decorator has a call proxies and class decorator has interface proxies and use a wrapper to intercept the later calls through functions and classes. Managing function and classes using and defining the decorator, then via the decorator basics, and then we come to the current section, that is coding function decorators. So we discuss the tracing calls, which is the output is come to be a 6 spam 1, and today we discuss the decorator state retention options, and there is a class instance attributes, enclosing scopes and globals, and closing scopes with non-locals, function attributes. So in that so so the decorator state retention options generally you need to be support the multi decorator objects and multi calls, but there are number of ways to implement these goals. Instant attributes, global variables, non-local closure variables, function attributes are used in retention states. So class instance attributes, so okay, yeah, so in that class attributes we have the class like class, then tracer, then function in it, in function self and argument of self and func, and then the self dot calls, then 0. Yeah, same, I think so. Yeah, this same. Okay, so we copy that function for tracing calls, and then we applied same thing. Yeah, and uncomment it this way by control question mark button, and then we have then it func, then function, then calls, and we have that star, this is extra, then so okay, and then we have calls and this, and then we have written the this way tracer decorator, and then we have the again decorators tracer, and then we have the def x argument x comma y and colon, then we have the print x comma y, and then we say, then we call the function. Okay, so in that first we take the state, and that we have the state y instant attributes, that is the state. So it is a state y instance attributes, and in that function we just on the decorators. So like we have on the @decorators decorator, then we have save the calls, save the function for later calls, and so we have this save func for later call. Here it is, and this is on call to original function. It's a on call to original function. It is, and that so we have the decorator tracer, and this is a function spam. So this is same as spam assign as tracer spam, and then we trigger the tracer. So this is a okay tracer spam as tracer as right spam, and this is a trigger tracer dot init this way. So this goes to this function. So we have that. Okay, then we have that same as for that, same for this is @decorators. So same for this okay, sorry, yeah. So under that spam, the function is sorry, yeah, spam the eggs is come, yeah, okay. And then we have wraps the oh sorry, this to be as the power of y. Yeah, so yeah, very cool. Yeah, wraps the x in a tracer objects. This is okay. Then we take the then we call the function spam, then pass the parameter or argument as 1, 2, 3. So it's really call the tracer instance and run the tracer call. So it will be like if we just run it okay, sorry, yeah, so yeah, so this way. Yeah, so it's called the call 1 to be spam, and then a call is come. If we so this way we really calls the tracer instance, and then the run the tracer calls this way. And okay, and then we take the another function like spam a dot 4 a assign and b assign 5 and c assign 6 this way. So same way argument can be passed by this way also. as a value, and then we run it. So it's called is this output is show that call to be spam. Okay, sorry, this to be as uncomment. Okay, yeah, and this shows the when I run it, yeah, so it shows the call 1 to be spam. Yeah, if we run that, it goes to that way. So it shows the call to be spam. Yeah, call to be spam. If we run the x like x and say 2 comma 16, so in that this spam is the spam as an instant attributes, and x 2.2 comma 16 is a really call the tracer instance self func in is egg. So when you run it, show this way call 1 to be x, and this show the 2 to the power 16 value. So it is 2 to the power not, but show the calls like yeah, 2 to the power 16, yeah, 2 to the power 16 the value, and then we say x pass the 4 comma 1, so like this, yeah, this way, yeah, you can say y signing 4. So when you run it, it show the call to be x this way. So it's this way, likely the original. We use the class instance attribute to save the state explicitly. Both wrapper function and call counter are pre-instant information. Each decorator work its own copy. So output so this way, and we getting the and okay, this is the uh, calls class instance attributes, and we jump to the enclosing scopes and globals. So like same thing. In the okay, this is enclosing, and copy that the tracer class, and okay, and so this is a comment, and okay, and we jump to that, like we copy this. So this is a class tracer, and okay, and we only need the tracer. So enclosing scopes and global, we work on the tracer. So I think so, yeah, so this things is to become okay, same output, yeah, take care, but the init functions is goes out, only the wrapper are there. So that is a this to be a def, and okay, and the nested is wrapper. So this to be a wrapper, and this is fine. In that function we do not need self, and this to be not needed, this to be erase, and this to state is a enclosing scope and globals. So we have just used a can use this. So we need a initial value of class of calls like 0, and this way, and we also we have to call that variable in the function. So we use global variable, global, then the calls this way, and then this way, and this to be fine, and no self is required. So this is no self is required again, yeah, and this is this, this is not, and this is not. So this is the, and this on call is supposed to be instant instead of class attributes, and we have the calls is global, not per function. Yeah, call, so global not per function. Okay, so when we run it, so show the error. Okay, sorry, self is not, and self when we return it, we return, and outer is also has it some written. Return wrapper. Yeah. So when I run it, show the syntax that tracer. Okay, some tracer has to be an argument function. Func. Okay. Self not, then calls. Yeah. So it works same way. Call 1 to spam 6. Call 2 be spam 15. Call 3 to x is 65536, and call 4 is 256. So this way we have the enclosing scopes and local, and okay, and we jump to the enclosing scopes and non-locals. So same thing is used, but in the in global scopes, enclosing scopes and globals, this for this function we move the counter to the common global scopes to allow it to change it like this, more meaning than it will share by each wrapper function. Unlikely class instance attribute global counter are cross program, not per function. So counter is incremented for any tracer function calls. So they're like this way, call 1, 2, 3 and 4 incremented. Okay, so we jump to that enclosing scopes and non-locals. Same function is used, but for non-local we have to be call to be not outside but it to come to be inside. So like this, and this to be as a comment, and okay, yeah. So like this we have the, so in that non-local, so it's to be non-local, the call to be come inside of that function. This way, and for non-local, and we type the non-local calls. So call is not global. Call is not global, but call is per function. Call is per function, not global. Call is per function, not global. This way, and this way, and this is same. Okay. In this scenario, spam 1, 2, 3. It's really called the wrapper. It really called that wrapper function, and bound to the function, and bound to that func variable, and this. Okay, and when you run it, so it show that this way the output is different, not incremented. Call 1 to spam 6, call 2 to scam 15, call 1 to 1 not call 3, not is call 1 x to x 65536 and call 2 to x 256. So this will be really call the wrapper and bound to func, and this is wrapper calls cam, and ag 2 comma 16 is really calls wrapper and bound to x, and this is a non-local calls as per decorator here. So so enclosing scope variable is not cross program global, and each variable function is own counter again for class and attributes. So we jump to the function attributes. In function attributes we have that same thing this way, and okay, this way. Yeah, so like def, then func, then enclosing. Okay, this is good. Func, then calls, and call there to be not come, and like this, and okay, and no locals is called in there, this to be as deleted. Okay, okay, and we have so this, and okay, and then we use the wrapper function attribute wrapper dot call this way. So this is the call as per function, not global. This way, this func will work as per function, and this is this, and then we have to be initiate the call function as calls assigning to 0. So this is this, and this is this, and when we this is same, and when we run it issue the error like func dot there is to be a wrapper. Yeah, okay, yeah, so it's like this, and okay, so it's really like the non-locals work like a non-local this way, same as non-locals. So it's work only because the name wrapper is retained in the enclosing tracer function scopes, and when we later increment the wrapper calls, we are not changing the name wrapper itself, so it's a non-local declaration is required. So it's like a non-local, yeah. So its response is like this way. Okay, so we jump to this is a okay, so we have the class blunder 1 decorator method. In with that we have just we first class based tracer function decorator in that, and in that we have discussed the yeah, in tracer we have this class based decorator functions, and okay, and we have the we have like decorator method that will work the same, and okay, so on the really downside to for assumption is we applied to class method, and we have that we have the class based tracer decorators, And okay, we jump to class. This func, okay, this to be as comment. Sorry, this has to be a comment. So we need a class tracer, not function tracer. So we come to like we have discussed a class tracer like this way, class tracer. So we copy that way, and okay, here it is. This is as uncomment. Okay, so here it is. So here we get the like yeah, this way. Okay, so we have the class tracer, then in the init, then func call 0, then func, then the calls. So automatic set instant argument will be simply the include in the as a this way star arguments and double star keywords. So special arguments are there used in that argument way. And okay, so we have this on decorators, on the decorator this way, same thing. In that this in this we have just called the function, so we return the function. This in that we return the function. Okay, so okay, this is this, and we have just okay, we have just rub the X. We only need the spam, this to be as yeah. So this way it work. Okay, yeah, here it is. So we have this way, and okay, and when we run it, so it shows call 1 to spam and call 2 15. So it's run the tracer. Yeah, this will okay. Yeah, so this way this will runs the tracer function dot call function. So this runs the class tracer dot call function. And in another way we have just, if we just print this, if we check the this way and we just okay, this is same. Okay, and spam. Okay, in second run of that spam is yeah, second function run spam. The spam will saved in an instance attributes of previous call. Okay, in that we have just that like this work when we use some different things like just like we just copy this and just yeah, okay, just copy this and this to with comment. Okay, okay, this way in function we have the person, and then in it, then the func name is name of person, and then pay the something like bills, and in it, and then we have introduced the decorator inside of class. So we have the decorator like decorator tracer. Okay, we just this to be not as comment. Okay, okay, this also needed, so it's uncommented. We have the class tracer we needed in that. So we needed two classes, class tracer and trace person. This is the decorator tracer, and then okay, this will work. And we have this self dot, then we have that's like a self dot name. Okay, we just copy this and we just apply this self dot name and pay, self dot pay, here it is. So okay, and then we have the function that is give rise, and this, in that variable we have percent give rise work. Okay, this way. So this will work as like give rise assigning tracer, this. Okay, and then we have like self dot pay, which is assigning self pay multiply by 1 bracket 1 dot 1 plus percent. So self pay assigning self pay plus self pay assigning self pay multiply by bracket 1 plus percent. And okay, and we needed another tracer, so we just use this and we just take this way, this is and this. Okay, here it is. So this is this function is like a last name, and okay, last name, and then self is there, self, and we returning it, and we return something self dot name, then split that name, split, and we needed the last name, so we need a -1. Okay, this is okay, and this also, when the decorator is before that dot function, so it's work as last name dot assigning tracer, then this way. Okay, and then we have remove this. Yeah, the two functions are there. Okay, this way. Okay, and then we have the like instance class, the instance of class like Bob, then person, then comma name of the person Bob, like Bob Smith, then 50,000, like that we have to pay 50,000 bill, and that okay, and that tracer will remember the method funcs, and that funcs, the tracer will remember the method like funcs, this way. And if we run it, and it show okay, we have just Bob Smith. Okay, just, and we just Bob dot give raised by like percent like percent 0.25%, like 25%, then will it be okay, it show the error because okay, some missing percent required percent. Okay, okay, with the percent. Okay, percent. Okay, pay dot percent, and the percent is there. Okay, that's fine. Why it needed a self? Okay, call one to rise. Okay, this to be as a one comment. Okay, funcs, and we have just returning the function, then this then self dot calls, then function, then def calls, then init class tracer funcs. Okay, it's fine, all are fine. I think some error in this, I think so. Can I run it? Yeah, if the error function give person dot give required tracer introduce. Okay, give rise this is this. Okay, sorry, call it not necessary. Okay, okay, this is this, and I require a person. Okay, give rise. Okay, oh sorry, 0 is not, I think so. Okay, one position argument. This to be some float. This show again something. Okay, so yeah, it show the error. Okay, so it show the type error, give rise missing one required positional argument percent. So okay, and this show the error, and we again test the another method, like we test the test the another method, like print bob dot last. This will also show some error like this, person name is missing from the missing the position argument self. So root of the problem in this self arguments of the tracer calls class calls method, is it the tracer instance of or a person instance? We really need both as it coded. The tracer of decorator states and the person for routing on original method. It really the self must be tracer object to provide the access to the tracer state functions. It's called and funcs. So it's true whenever the decorator is simple function or method. Unfortunately, when our decorator method is rebounded to class instance object with a call with the calls, the Python pass only the tracer instance to self. It does not pass along with the person object in the arguments. In second class, it does not pass it. So that is a Okay, so like so Python will like bounded method object containing the subject instance only when the method is simple function, not its callable instance to another class. So that is a problem of that. Okay, we jump to like okay, there's a okay, yeah. So like we have this to be as this way, yeah, yeah, this will fine. Okay, so we jump to like okay, this to be as we jump to like we have using the so the solution will be like using the nesting function and using nested functions to decorate methods. So like nested, we using nested functions to decorate the function. So like we have here it is. So we have the like this way with the tracers and def. Okay. A tracer a, a call tracer decorator for both function and methods. Like we have this like so we have them like the we have a call tracer decorator for both functions and methods. You can so 2 minutes. Can you note it down? We have to come to 2 minutes. Please note it down that points. So welcome to class. So we using nested function to decorate the methods. In that we have the call the tracer decorator for both function and methods. So like this we have like we have the that's this code. So we alternatives applies the like we have just take this as a class like this. So we using like this way. So we have the like the def tracers like the we have the tracers like we have the tracer like this. Okay, so we have the class person, then this this. Okay, we have this. Class tracer this and then this. So we do not need this and we have just used the like the functions, like simple. In the class we use the tracer we use the tracer functions. So we just rub this and then we copy the, yeah, this way. This were fine, I think so. Yeah. Okay, we need the non-locals. So non-locals are codes are for, like, this is a global non-local. Yeah, this will be fine, work fine. Yeah, just to be copy and just apply this, and this we have copy this and uncomment it. So this is a, like a yeah, this to be a, this is a non-local scope, and this is the calls. Then wrap, in place of wrapper we use on call, and then calls like this, same function calls, then return the func, and this to be written on calls. Okay, this is fine. So we using like sorry, using the function attributes and enclosing scopes of non-locals. This scenario, we using this scenarios in this way, like we using this scenarios. Okay. Yeah, this is the same. Yeah. And okay, and just we implement the if name, like we have name is equal to main, then we take this as a in the inside of this. So like okay, this to be inside of this, and okay, and we have just used the x. Okay, this to be this. Okay, x dot n, and this x32 tracker spam. Okay, yeah, this to be copy. Yeah, the code is from start from this, you can note it down, and then goes for this, and just, and then between that we used decorator tracer. Here it is, and just in place of x we use 2, and y we have n. Here it is. So this is on call. Remember spams. This is same. Okay, 1 2 we pass in same, and then we print the spam x 32. So it is this way. When you run it, show the error like this way. Why show the error? We apply the simple functions, spam tracker. Okay, oh sorry, this 2bs, and yeah, this will work fine if you run it. Decorator is not defined. Okay, the same, I think so. This is to be defined. Okay. And then we have the traces. Okay. So we have to not define. This is a so we use if name equal to main. If we run it again, it show that tracker is tracker is not defined, but let's define it like this way. It should be work. Okay, this is same. Okay. Okay, sorry. Oh, this to be is uncomment. Okay. Okay, yeah. And this will work. Yeah, this work. So like this way, we have the call one to spam, and then call one to spam, and then we have call one to spam 6, the output of this spam, and then we spam this, and then call 2 spam, then 15, and then we call 1 to x, this is 32, 2 की power 32 is come this way, and then we print the x 32, so it did not return anything, so it's written none, and then we call the okay, then we call the class. So this is okay, this is for this is the okay, this implies the to simple function, and in this class we have applies to class level method functions 2. This is so this is this, and this is so we this, and then we print the method. Okay, though this is count, and this is okay, and this for this we have just take this simply like Bob 500, then and we have signing person, and we say like Sue Jones had to pay 1 lakh. Okay, so we just print the Bob name and Sue's name. Yeah, and then we say that Bob's rise to 1 and Sue's gave rise percentages 0.1%, yeah, 0.0, yeah, sounds the same, and then we print the init Sue dot pay and last name of Bob and Sue last name this way. When we run it, to show that okay, this show that like this way. So it start from like we did the Bob dot name is Bob Smith and Sue's name is Sue's last name. Sue's name is Sue Jones, and then it's call one to give rise. This comes to okay. This comes to call one to give rise. So it's this give rise is like this, and okay, and this the decorator used to its decorators comes to okay. So it's comes to this on calls, and on call will return the this return the calls one to function name is give rise. So it's come to decorator, and decorator will return and then it's come inside that function, and it return the like this way, and then like this way, and this call to give rise to this. So again that there are so there we just pass that like that we have just passed the okay, we pass also the Sue give rise. So another call is there, call 2 for Sue's is there rise, and we getting the okay, we getting the only one value of that. So this will as uncomment. Okay, again we run it. So this will work fine. Yeah, this way. Okay, it in previously it increments with Sue's give rise also. So in last we just run it again for the Sue's, and this is work fine, I think so. Yeah. Okay, it's print the Sue's values. Okay. Yeah, sorry. Given different way. Just this to be as copy and this to be as comment, and then we say this, and then we print the Bob pay. Here it is, and we run it. So for that first one calls is Sue, call one to give rise, and then its values 11 that is 11 1 lakh 10,000, and then print in it, so it's give in integer values, and then we go to the last name, and last name function we have before that we have decorator, so it goes to the call tracer function tracer, and then we have call one to last name and call to last get the like the Smith and Jones, Smith for Bob and Jones for Sue, and for Bob we have class call to rise, and let's give the this way. So we have this. Okay, we have that class this, and then we go to time, we have this using the descriptor to decorate methods. In descriptor method we have okay, this same thing, class calls wrapper. Okay, same thing is there, class wrapper, class tracer, and we have the class decorator. So we decorator So we have the class like this, and then wrapper is this. Okay, you can note it down that okay, this is wrapper tracer, okay, and this is class tracer. Yeah, so we have just this way, okay. This way, and we have the tracers. So like we have okay, class tracer is this, okay, just copy this, and we just come to our this way, and this to be as comment, okay. Yeah, so we just goes to this to be as uncomment, and it is, so this is in it, and this is calls cell.printer, and it returns, okay. Yeah, this is work fine. And then we have the wrapper class. Yeah, wrapper is, we used wrapper before, and this is wrapper is this for class wrapper. We don't want class wrapper, okay. Yeah, no, we have wrapper, but it will work for different. Yeah, okay, this will okay, okay, wrapper not, yeah, okay, okay. Then we have the class wrapper, just def, then this init, and the argument is description, and then subject like sub, and then self dot disk, disk, then self dot sub to assign sub, this way. And we say again another function is f not call return self dot descriptions, self dot subject, then subjects, then this just to become, copy this way. So this is on decorators, and this is yeah, on decorator, and then we have you have that decorator plus descriptor, then we save the function for later calls, then call contour original functions, this is for fine. And then we have the another function that is def dot get less instance and owner, and then we return the wrapper calls a wrapper function self dot instance. Okay, this instance passed to this. Okay, and this will is on method attribute fetch. Okay, this will work on this wrapper this. So this will like this init this class wrapper init function will save the both instance. So it save the both instance, and then we have this. Then we do the calls back to decorator descriptor. This can okay. This will calls this way, and this is okay. This will work. This is okay, and this will okay, and this way. Okay, yeah. Okay, and then we have the then we use the using the previous one spam and then the class dot tracer, same code. This way we just uncomment it. This way, okay, spam dot decorator this way, and then this, okay. You remove the x, you can call person init this, okay, this way, and then we run the whole scenario for again. And we say this. Let's work. What should the error person not define? Okay, you have to define the person. Spam dot this. Okay, we use the we use this. Yeah, it would work. Yeah, this way. Yeah, it will work. Call 1 2, then this way, and call 1x, then Jones this way. This is work fine. Okay, this way it work also. This will also work. Yeah, you can note it down it. So you can note it down that. So here it is. So this is a decorator function, invokes only in call and never revoke it get. So decorator method invokes in Yeah. 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 Okay. Decorator method invokes in getIt first to resolve the method name fetched, and then object returned by getIt in the subject class instance. Then it invokes to complete all call expression, there, thereby trigger the decorator's call on this. Okay, here it is. So like we have this. Okay, this way. So we jump to the timing calls. So like timing call, we need a like import the time. Like that, we have timing calls like okay, timing calls like we have the timing like timings. We have and then this same thing, same scenarios. Call is there. Okay, yeah, this to be a same. Then timer is required. Timer import time module and system module, and then we force variable assigning list if system version information of first is equal to 3, else is lambda capital X comma this way. Yeah. So like this way we have okay, we just take as a this, and then we use this scenarios init method function, then function attributes, call timers this way. Okay, we have just like timer setting, we have the like decorators, then we have to take this way. Init timer, then init timer dot this, and func is the func func, then func, then we have func like this way. We have the func, then all time assign it to 0, and then we have call, then this, and we have this, and this self dot func, not descriptor as func, yeah, and it will not return, it will result assigning. Before that we have just used the start variable assigning time clock time clock time clock this way. Yeah, okay, it is. We have ellipsed assigning time clock minus start, so we're getting the difference of that time. And then we have the self dot all time assigning to all time plus ellipsed. Then we print the self dot func dot name function name, and then we comma, then ellipse comma self dot all time. Yeah, this way we have, and then we return the result. It is. So we have the decorator timer, and then we have the function list com then n, and then we have return that x की power 2 for x in range comma n, this way. And we have okay, and okay this way. So we have this timer, and then we have that timer decorator. Then we have another function that is map call dot n. Then we have to return force, then map, then lambda x to x expression is power 2, and then this, and this is to be a range power n. This is, yeah, it will work. Map okay, yeah, it will work. Yeah, and we say some instance of that function result assigning list comprehension 5, and say this way when you run it. Clock module is okay, we have to import it. Okay, timer, okay, we have to import it. So like we have, okay, we have to be imported. And okay, how to invoke that? Yeah, this is this, okay, dot this. No, for module we have like debug here. It's not as this. Okay. For that installation we have needed a okay. Time module. Modern not look. Acha, okay. Clock is not there. Okay. Clock is not there. Again when run it. So show the error. Why? We copy if we run it in the that. Why does it show the error? Show that is removed and we have present time. Okay, so we can use the present time. Okay, this will present time. This will work, I think so. Timers has no subjects. Okay, why? Timer has no subject. Cell dot. Oh, sorry, not to be present. Okay, yeah, it will work. So list or comprehension. Yeah, this will result as this way. To power this and this will come. Yeah, and this will work for result, like result assigning to map. Then we fire the 5, so it will return like this way. Okay, you cannot then we have decorator. Okay, for decorator versus per call timing, so that will be like we have that function list comprehension, and then we have the like this way, and import the timer. Then timer like we have per calls, so we have just like okay, we have the like this as this list comprehension. We have the timer dot total import the timer. Okay, sorry, we import the timer yes, say timer, sorry, timer is already present, so it is the timer dot total. Yeah, timer like this. Okay, sorry, this should be so we have the decorators like this way, and we saw that two can we do timer dot total is can be work. No, it's not present. So we have time int. Okay, time if it time dot total. No, total is not present in that. Okay, so okay, so per calls we have that we have the list comprehension case of decorator test code. So we have including the extra cost for managing the code like outer loops and function calls. In a non-decorator approach would only be the subject function to be used with or without timing. So but it would also be like complicated when call signature when time is desired. We needed to add the code at every calls instead of once at the def. So for that like this, and we jump to the testing subtitles. That is like we have same as list comprehensions. So we have just like list comprehension, make this comparison between list comprehension map so far. So we have the range as the iterator. So we do not compare directly unless we have host this calls out of the timed code. We relatively comparable and will reflect the best practice code in each line anyhow, but in the range interactions in iterations added extra times in only. So we decided to the tracker decorator. We will make this timing decorator reusable in other modules by intending the self-test codes at the bottom of the file of that init. So we jump to the adding decorator arguments. So we have just used the in place of like function we have used in place of class we use like on calls. Okay, on calls we used earlier also. Yeah, this way. Okay, this will same as this. Okay, on calls we use this, copy this, and we in the place of this okay, use this and this to be as a comment, and before that comment we just copy the decorators timer is there, decorator on calls. Sorry, hold to be as comment. Okay, yeah, this holds to be as comment, and this also is comment. Okay, and this to be as uncomment. Okay, this way. So in tracer we have the tracker timer, then the sorry, we have the label assigning empty. This is okay, and then we have the def decorator func this way, returning on calls and then returning the this to be erased. Okay, returning the labels. Okay, returning the something labels, just say labels or something like this. Okay, then we have some functions are there. So like and then we have some, okay, this to be as this, and this to be as this, sorry, this to be as this. Okay, and then we have some not written but print the calls. So here print the, okay, this way, and then we return the turning the decorators. Okay, and then we check that as a decorator timer, and then we have the sub list comprehension like this, compre then n this way. So we have like this ways as adding the decorator arguments. Decorator arguments like the labels we add that in that, sorry, in decorator arguments we have like okay, so decorator arguments like this way, this, and then we pass some symbol like this, and yeah, so we like the list comprehension is equal to timer, then this symbol is then the bracket list comprehension. So we add the argument in the decorator. So like this way we have decorator argument come, we have the coding properties, so we have just a label, for instance we might add as follows. So this code add as an enclosing scope to retain the decorator argument for use for later actual calls. When the list comprehension function is defined, the Python really invoke the decorators uh, decorators result of timer run before the decorator actually run. It will return the decorator when it remember the both arguments and original functions. So like we have the time, so we have to import the sometimes like import a time, and then we have the this, and we say like this phase tracer trace dot true, something like this, and they said something like this codings are to be. You can use this approach also, like this phase also. Yeah, you can say some class in place of, like we can use class timer. Yeah, say okay, this to be a same, and after that we use class timer like this way, and this to be like this, and here the like times. Okay, so we have the like this way adding the arguments. Okay, timer, then we have like def in it all time, so we call this, yeah, this to be copy. The timer is class to be copy. Okay, this way, and okay, on calls are required or not? No, yeah, this to be raised, and we have just needed a bunch of codes. Yeah, so like this way. Okay, and then the we calls, then this result. So we start is this and result for this and enclosing, and then we have the self attribute this, and then we have to pass the conditions. We check the tracer is present or not. Like trace is initiate, by default we trace as a true, so it will come if, then like format, yes, say format is assigning like percent s, then space percent s, then colon, then percent 0.5 float, then percent 0.5 decimal float is this, to decimal place is 5 in this way, and then the values is assigning as label comma self dot func dot name, then ellipse, then self all time. Yeah, and then the print the format percent values this way, and then we return the result, and then we returning the timer. Yeah, the timer. Yeah, this was true. Yeah, this was, and okay, and then we use some like this is adding the argument as decorators. So we jump through like timing with decorator arguments. So like timing with decorator, I mean we have to import some system, then we use from time, yeah, sorry, okay, this will check, okay, force, fine, and we use, yeah, you say like we have this to be removed, and this is force, yeah, same, and then say decorator timer as labels, decorator arguments, and string list cc, something like this, and this list comprehension and then return. Okay, why did not work? Okay, yeah, it worked. Return star x की power 2 for x in range n, and then we run. Okay, and then we take the this way, and we this way, and we take the map function decorator. Yeah, so okay, and we just take the argument as this way. Assigning, we just run it directly. You can assign the result. Okay, and when we run it, list comprehension is not okay. Okay, yeah, so it's work. So it works as this timer will return this, and then we have get the result. And so we jump to the coding class decorators. In coding class we have the singlet classes. So singlet classes we have like we have just it's same like we have just used the previous codes like Bob Suze and okay, so we have like those previous code like Bob Suze, and we just copy this person, Bob Suze person. Yeah, this will be as copy this self page, and ours is there, name is there, something page there, and then we have this spam. In it, just copy this, and we just have to pay. Okay, this to be copy, and okay, so we just copy this, and we just this is a comment. Okay, self named and hours, then self rate dot rate, and we pass the like argument like hours, then rate this way, and we have the like before that we have like instance comma this empty dictionary, then def dot singleton, then a class, then def dot on calls, like on call. Then we have star arcs, then double star key, and then colon. Then we have if on call not in instance, then it's pass the condition instance will add a class, assigning a class, add of a value, a class as star arcs and double star key, and then return the instance, and then return the on calls. So this is a decorator singlet. So we mentioned the decorator singleton, this, and we say okay, and we say the self pay is to be removed, pay, and then we have said okay, this to be removed, and this is return the self hour, okay, and this to be self dot rate, and this to be a return. Yeah, okay, this will work, I think so. So we have just this and angle. I have some decorator singlet, and then we have call class spam def non init argument wall, leave some values are there, and self dot attribute has value, and when we say value, and when we say pass the as instead of class bob person, string bob comma 40 comma 10, so like it print the bob name. Okay, person this our name, the fine name, yeah, is to be printed or not. Oh yeah, printed. Oh, sorry, name. Dictionary object has no attributes. Instance class, yeah, it's written the bob, yeah, it's work fine. and then okay, and then we introduce the some we have some spam. So we have that class instance of class of spam, then the like value something like 42, so it return. Okay, we have to print the attribute, sorry. So print x as attribute, so it return 42. Yeah, so it worked fine. So we have like okay, then this way, and okay, we have this. For that we have that singlet. We all the coding alternatives. Coding alternatives we have just used like in that singlet. We can use also single class like this. In the place of this, we can use the like in place of this we can use like this. For this not, we not use this. We can use like okay, just copy this, and okay, and yes, this we can use like this, and something like alternative we have just remove the decorator and just like singlet singleton again, then in it, then the like the class, then this, and something like this, then self dot class, assigning a class, and then self dot instance assigning none, and then we have some this has something like we have def and call and say if self dot instance is equal to none, then we have self dot instance assigning to self dot a class, then this comes to this, and then we return self dot instance. So it will work also this way. You can use the alternative codes. So we jumps to like tracing object interface. For tracing objects we have like we have just use a like we have just used a wrapper for tracing object interface. We have the like just to be as command. Okay, and then we have like we have some class, then wrapper, then def init, and then we have the object, then self dot wrapped as object. Yeah, and another function is get the attribute in place of item we have attribute name, and then we have print this as trace, then we have attribute name return get attribute self, and then wrapped dot attribute names. So this will like a VM instance of that wrapper class, and then we have to pass the list 1 comma 2 comma 3, and then we say list, we want the list of x as keys. So it will print the list has not attribute of keys. Sorry, list, so we have to append it. We have to append it. Append in that list we have append the 4, and when we print it, sorry, and when we print it, trace is append. So it show the delegate to list method. And if you want the method, if you want the value of that instance x, so we have wrapped, and when we run it, it did not show anything. Why? Because wrapped and not wrapped. That object this, and set this, return this. We have to print it. Sorry, print that this and this. It will. It will run 1 2 comma 3 this way. And so we jumps to tracing interference with class decorator. For the tracer, like we have we'll have the def dot like def. So we have the code like def. We have the like code def. This is a wrapper class. If we say the def function tracer, then a class, and when it is a class wrapper, in it we used self dot fetches as 0, and and we say this object we have used this fetched and then wrapped as, and in the place of object we have a class pass the this, and we have this, and we have this, and we have the self that dot traces fetched. We have the self dot fetched increment with 1, and returning this, and then when return the wrapper. And in that we have used if name is equal to main colon. So we use the decorator tracer here. So this is a function decorator. So we use we use a spam and then person. For person we have this. So we have this code. For decorator we have This to be one comment. And for another decorator we have tracer, we have spam, def spam. For def spam we have spam, like okay, yeah, spam is this, yeah, this spam, yeah, so spam like this way. Spam, and argument of spam is, oh sorry, we have class of spam, sorry, not class of spam. Work as spam dot tracer spam, then we def display self, and then print string spam, multiply the string with 8, this and this, and okay, so this will work. Okay, we have to be food instance of that class spam, this, and say food display, and I run it. Display, yeah, display, yeah, so it show the traces, yeah, so it show the trace like this, traces display, and show that display, it is the traces display, and then spam 8 times. So another class we discussed the applying class decorator to built-in types. So that's all guys, thank you.